Have you ever wondered what it's like to sit in on a magazine editorial meeting? Well, this is your chance. You're listening to Salt Lake Speaks, a monthly podcast where our editors, writers, and staff dig deeper into stories, chat with newsmakers, and talk amongst ourselves about arts, culture, food, music, politics, or whatever else might strike our fancy. After all, we are Utah's biggest fans. Hi, this is Andrea Peterson, and you are listening to Salt Lake Magazine's own podcast, Salt Lake Speaks, where we talk about anything and everything that is going on in and around Utah with all our local leaders and all the fun current events that are going on. And joining us today is Brian McInerney, a hydrologist for the Forecast Office, and Lisa Verzella, a observations program leader and forecaster from the Salt Lake City Forecast Weather Office, which is all under the National Weather Service. Thank you guys for joining us today.
Thank you, Andrea.
Yeah.
So we kind of had you guys come and join us because the weather's been a little weird, not just this year. I mean, it has been for a couple years. And I think a lot of people are trying to figure out what's going on, especially us who live in Utah. I mean, we are driven by our seasons, whether it's hiking in the summer and camping, or of course our snow industry, which is huge for tourism and just huge for us winter outdoor junkies. And I think, you guys can talk a little bit more on specifics, but it used to be, snow season, Thanksgiving was when people just came and flocked to Utah to kick off ski snowboarding season, and now we are pushing those dates back and back. Our resorts try to open up and then they close. Like that's what happened this year. We had some snow, and right now we have snow in the forecast, but it's still a little bit with us. So whoever would like to jump in, Brian or Lisa, and just kind of talk about what is going on in the weather. I know it's a broad thing, but what is going on out there?
Okay, well, I'll kind of jump in with the current, what we have now. First of all, it's kind of important to remember that climate is basically weather averaged over about a 30-year period. So you're dealing with long-term patterns, and climate is versus weather. Now, weather is kind of the localized, 3 to 7 day, maybe out a month. They say weather's what you get now. So that's what we're dealing with now. We have had a pretty bare precipitation season since it started, this fall. And right now we're kind of stuck in that inversion pattern. We do have a series of systems moving through, so it's not like there's no hope. We will scour out every once in a while, but we pretty much have this kind of general inversion pattern. And inversion is when the temperatures down low are warmer than the air aloft. Basically, usually as you go up in the atmosphere, the air cools. But when you have an inversion, it actually warms up. And so if you get very stable air, the air doesn't mix, and all of the pollutants and the things in the atmosphere are kind of trapped.
So you're saying that it kind of was a little bit crazy that we settled in a valley and we have a big city that's growing, but we have this natural phenomenon out there that kind of comes every winter?
Yeah, it is. It definitely is a pattern. The longer the inversions stick around, the more you'll see those pollutants in the air. But we are just kind of trapped in this valley. Like there's a lot of topography that really makes a difference.
Now, is the inversion something that is affected by? I mean, I know it's kind of hard out there, especially in the political climate right now, to say what is climate change and what is scientifically going on. But is the inversion something that's happening more often or lasting longer because new climate patterns?
It's definitely caused by climate change. These are getting worse. And when you look at the frequency of inversions, we're going to see more of these. And it's what you consider called a dipole. The western U.S. has a big high pressure ridge. It's centered around the west. It deflects all the storm activity. Everything coming off the Pacific gets shunted north, and then it drops down in the Midwest, and then it circles back on the East Coast. The Midwest and the East Coast are really wet, really cold. The West is really dry, and that's due to this dipole weather pattern that was the dominant weather feature from 2012 to 2016, and now we have it again. And the question is, why are we seeing so much of this? Because we used to get a little bit of it in January, and then it would break up and we'd get consistent storms. They were quite regular. What we're seeing now are storms coming out of the Pacific Northwest are less frequent, they're more intense. These periods of dryness with inversions are becoming longer, and we're going to see more of this. And when you look out over the Pacific, that same low high, it's like rocks in a river. what they're finding is areas of the Western Pacific, there's an anomalous warm pool of ocean water that is driving this pattern of low-high as opposed to weather that just sweeps in every week or so and brings a storm. Unfortunately for the West, the high pressure is parked right over us, and it's really hard to move that out. It has inertia, it persists, it doesn't go away, and we're stuck in it at least till early January. Stanford University has done research on this, and they're finding that it's mostly due, these prolonged periods are mostly due to a warming climate, and we're seeing this, and we have to get used to this. We're going to see more of this in the future.
So does that kind of mean that, especially for us, snow bunnies out there, does that mean we're going to have less and less of a winter season, or is it going to be delayed, or is it different, or can we even predict that?
Yeah, so what we know now is that the fraction of precipitation during the meteorological winter, December, January, February, used to be totally snow. Well, now it's changing. We're getting more rain into that, especially early in the fall and later in the spring, and we're seeing that. Also, we have temperature increases that cause premature melting in February. And we've seen that the last 2 years. Doesn't mean every year you're going to get this type of weather we're seeing now. It means the trend is bringing us to more of these high pressure events, more storms that come later. They melt earlier until eventually, right around 2035 to 2065, areas that are 100% snow covered in the Wasatch Mountains will only be 50% or less. Now we move forward in time to 2080, 2100, we're going to be a rain-driven hydrology. We won't have snow in the Wasatch during that time in the winter months. So at what point do the ski areas find it's not feasible to run a business? That's the problem, and this is what we're faced with. And we've got about 2 decades before we have runaway climate change, and that's a big problem.
Wow,
we need to wrap our heads around this.
This is recent. I mean, not recent. This is coming.
We're in it now.
We're in it.
We're in it. We're doing it. This weather you see now, these prolonged periods of high pressure, are a direct result of what we see with a warming climate. The scientists have been talking about this for 30, 40 years, and for most of the time, we've just listened and just kind of gone on as business as usual. Now what we're seeing are the results as we speak. The seasons are beginning later, they're ending earlier. We're seeing more rain during this time. Storms coming out of the Pacific Northwest are less frequent, then they're more intense, and this is only going to get worse unless we can wrap our heads around putting out CO2, methane, and nitrous oxide in the atmosphere and reducing levels that used to be 250 parts per million that are now 408 parts per million.
Talking in layman's terms, what does that mean? Like the CO, like us as consumers, as Utahns, what are we doing that is causing that?
So when you look at Utah, coal-fired power plants, the oil and the gas industry, diesel trucks, all of these are putting out CO2 into the atmosphere. Cattle operations are methane-based. They put a lot of methane in the atmosphere, and we're loading up our atmosphere with these greenhouse gases that reflect the nighttime heat back into the atmosphere and don't allow it to go back into space. The science is very clear on this. There is no debate on this whatsoever. When you look at the literature that's out there, 97.4% of the scientists that publish in accredited journals say it's happening, we're causing it. Now it's a function of what are we going to do about it? Because we've got about 2 decades before we hit what's called a tipping point. And the tipping point then produces all these feedback loops, and then we have warming like we have never seen before in our history.
Lisa, why don't you talk to us a little bit about some of those statistics, those snow totals that are changing and evolving over the Wasatch Front?
Well, as the observations program leader, I run our local program called the Cooperative Observer Network, which is a whole network of about 100 observers all across the state and southwest Wyoming, and they have been keeping daily temperature and precipitation records for decades. It passes on through families and at institutions, and they're really great records of how things have changed over the years. And so we're seeing a lot of those changes in the data. And for example, like we've kept records in Salt Lake since 1874. And though we have basically an average snowfall of about 55 inches a year, that has changed over the years. We've had great years of like over 100, and we've had paltry years. But since 1874, we've seen a decrease of over 10%, maybe about 13%, just from our daily reporting. But then you get up to altitude, and say up at Alta or Brighton, we also have cooperative network stations up there that have been in existence for several decades as well. We're also seeing a decrease in snowfall there from our records. Anywhere from 8 to 10 or 12% at Brighton, and a little less at Alta. So we're seeing those kind of correlated throughout the state in both the high elevation and the low elevation sites.
So we have these obvious numbers, and you guys are scientists, and you have these statistics, you have this data that's been gathered. You know, is there a reason that things aren't changing, or are they changing, just not as quickly? You know, what do you guys see as scientists? And I know politics it's a hard thing because there's money involved and there's voting involved.
Yeah.
So what do you guys experience?
So when you look at the local level, people are wondering, what can I do? But then you take another step up at the city levels, and the cities are doing really well. When you look at Park City, Salt Lake City, Moab, Aspen, they're all in a cooperative to be zero carbon neutral, basically not putting out any carbon at all. But then when you move up to the state levels, we're not doing so well, and then when you look at the federal level, we're not doing well at all. And the problem with that is you can say, well, that's okay, we'll get our heads around this when it gets really bad. The problem is that tipping point. If we hit 2 degrees centigrade globally, then we have what's called feedback loops, where an example of this is the Arctic ice cap melts. It gets smaller, radiation doesn't reflect off into space, it goes into the ocean, warms the ocean, which warms the atmosphere, which then melts the ice caps, then which more radiation goes into the oceans, and it feeds on itself, and it just propels. Another example of this is the methane that's been frozen in the ice caps up around Siberia, northern Canada, Alaska. It's melting and it's releasing methane into the atmosphere, and methane is 32 times more potent a greenhouse gas than CO2. That warms the atmosphere, which melts more permafrost, which releases more methane. Once we hit 2 degrees C, and some scientists think we might have already hit it, then we have runaway climate change. And when you look at temperature levels, they become unsustainable for the human race down the road. How far that is, we don't know. The key is we need to stop, and then we need to figure out how to scrub CO2, methane out of the atmosphere to get them back to pre-industrial levels. We're not doing that right now, and we have a window of opportunity. Once we pass that window, then there's great uncertainty how we're going to get our heads around this.
I mean, you mentioned previously in this when we were talking that like we're in it right now. Things are changing, and it's changing rapidly.
Yeah.
Are we almost past the point of no return? Is it scary? Like, I mean, what as people out there, what should we be thinking and feeling?
So what you need to do is read the planet, kind of step back, be objective, not just everyday stuff coming at you, but look, have we ever had massive wildfires in California? It's December. And we're burning California. We've just had a hurricane series in the Gulf that produced record-breaking precipitation. We've paid out hundreds of billions of dollars in damage due to events that we look and you're like, well, is that really something from a warming climate? If you look at the science, when you warm the climate, the energy in the atmosphere becomes much greater. What we're seeing here at the local level are thunderstorms that are much greater than we've seen in the past. Rainfall intensities are increasing, plus we have an influx of population to the parks in southern Utah that they know nothing about flash flooding and how it works, and some people consider it a Disney ride. You go into slide canyons, and it's really a dangerous situation. We're seeing this at the local level. You see this globally. It's happening. The question is, what are we going to do about it? How are we going to get our heads around this to reduce the amount of greenhouse gases in the atmosphere in that 2-decade window? And we're really not making a whole lot of progress at the state and the federal levels in the U.S. The rest of the world has seemed to be grasping this and really getting after it. But when you look at the city levels and local levels, they're doing really quite well, trying to do their part. But I think people are unsure of how to proceed on this.
Okay, you guys are scientists, and
right?
You have the information and facts with you, and the lines start getting gray and weird when you bring in politics and opinions and all that kind of stuff.
Yeah.
As scientists, is it frustrating to have these numbers and these experiences and these obvious facts in front of you for you guys aside from just giving the numbers, what can you guys, do you guys feel like you're at a kind of a wall and a hard place?
The key really is when you understand science, you understand how it works, and you have the scientific consensus behind you, it's really quite easy to just keep pushing the science. And our job is with the National Weather Service is to protect the people of Utah from weather and events like that will affect them in the future. So for us to go out and explain climate change is really a topic that people, about 10 years ago, I used to get yelled at. I would get people very unhappy about this. Now what you're seeing are farmers and ranchers that come to us and say, you know, our ranches aren't behaving like they used to. Our farms are not doing what it used to be. The weather is changing. Can you give us some guidance on this? How do we help? And for me, that's when I get empowered. I really feel good about explaining this to farmers, ranchers, to the water districts, those kinds of things, and giving them information that will allow them to thrive in their business. And also, when you think of what we talked about, we're going to get a rain-driven hydrology. How do we do water supply for the population of Utah if we don't have snow? So they need to hear this, and that's what keeps us going, is the idea that we're providing what's considered the truth on this issue, and let all the rest of the world kind of mess around. But that's our job, is to really drive the science, explain it to them in a way they can understand and take action on. And that's what we do on a daily basis. When you think of the forecast, watches, warnings for winter storms, for flash floods, severe thunderstorms, this is just one other part of the science. It's climate change, and it's coming, and we're seeing it right now. And the key is, what are you going to do about it? How is this going to affect you? Well, here's how it works. This is what you may want to do. This is how it's going to affect your farm, it's going to affect your ranch, and it's going to affect the water districts.
No, that's great. That's good information. So then, based on that, where can people go to get kind of daily, weekly information to help them plan out their day-to-day lives, and as well as information to how they can maybe prepare and help assist in what's going on out there right now with climate?
Well, in terms of weather, you know, we've got a really good website at the National Weather Service. We give daily discussions, and we give graphics about what is coming up, like what to expect with inversions, you know, when the next storms are. So all of the data that we get goes into our forecasting, both kind of short term and longer term. So you can get information to prepare for, you know, whatever weather you're expecting in the next week or so from the website, from the National Weather Service website.
And how can kind of the common person really like analyze what information they're getting to how to better their days and their lives?
Right, so when you think of the weather forecast, they can get a forecast for their house. They can zoom down and see within 7 days. What we talk about with the long-range forecast and what's going to happen with climate change, NASA does a really good job. If you just Google NASA and climate change, they've got what they did, and this is a failure of the scientific community, is to explain what the science is and what it means to you. We work for NOAA. They could do a better job. NASA really nailed it. You go to NASA and they show you graphics and they explain it to you how it works with the atmosphere. And I use a lot of their stuff when I give presentations around NASA.gov and climate change, and it just pops right out at you. And understand, there is no more discussion on this. Now what they're trying to figure out is precipitation levels. Were they going to change? How is that going to work? And then how fast is this going to warm? Because really most of the science that's been done has been underdone. They've projected that these things were going to happen. Well, in fact, the Greenland ice sheet is melting faster than they expected. The polar ice cap in the Arctic is melting faster than they expected. The wildfire season is growing faster than they expected. All of these things were forecasted and in the literature 20, 30 years ago, and it's happening, but it's happening faster. Now they're trying to wrap their heads around, how does this work with all these feedback loops? How is this going to do it? The models they're using are getting better all the time because we have better computing power. And then when they get done with it, they publish a paper. And before, the paper used to go into a journal that only those types of scientists could read. The general population can't read it, doesn't understand it, doesn't want to look at it. Now what they found is the scientists need to do better explaining scientific results to the everyday person in the community. And NASA has taken the lead on this, and they're doing a really good job.
That's good, because I mean, most Utahns probably can see it firsthand, tangible. I mean, we're outdoors. You know, you've got the farm country out in the U.S., they probably see it firsthand, but I know we see it with our ski seasons being later and later, our summers being hotter, or the flash floods, and I think that's great. So for our listeners out there, you heard it from them, check out NOAA and as well as NASA to get your information for your day-to-day living, and how you yourself can make, you know, even small changes that will make big impact to the climate.
Good.
So thank you, Brian and Lisa, for joining us. Again, Brian McInerney, the hydrologist for the Forecast Office, Lisa Verzella, Operations Program Leader and Forecaster, both come from the Salt Lake City Forecast Weather Office under the National Weather Service. You can listen to this podcast as well as others with Salt Lake Speak, Salt Lake Magazine. You can find this on our website at saltlakemagazine.com/podcast.